Hello everybody, and today I'm going to make the editorial video for Codeforces around 882, and also I'm one of the authors of the problem, so hope you like the problems. And let's start with the solution for first problem. So in the first problem, you are given an array and you are given an integer k, and you need to divide the array into k subarrays such that f of each subarray, a sum of f of each subarray is minimized, right? So now how do you do that? So first let's observe that for some array, okay, a1 an, okay, you have the value. What is the value? A2 minus a1, absolute difference. It's not a difference, it's absolute difference. An minus a. Okay, so this is the current value of the subarray. Suppose you break it at some position I. So a1 to ai is one subarray, and ai plus 1 to an is another subarray. Okay, so what is the value of this subarray? A2 minus a1 plus a3 minus a2, ai minus ai minus 1. Okay, this is the value of first subarray plus this is I plus 1, ai plus 2 minus ai plus 1 plus an minus 1, right? So what you observe here is this for k equals to 1. Let me change the color. So basically for k equals to 1, this is the thing, and k equals to 2, this is the thing. So what is difference it goes is that ai plus 1 minus ai difference is removed. Okay, if you add this, then these both have the same sum or the same value. So here what you observe is that when you have a subarray, you divide it at some position I, then the difference I plus 1, a of I plus 1 minus a of I is removed. That is not taken, right? And you want the sum of subarrays. So if you divide, this is subtracted. That's all. Other sum remains the same for any subarray. So now you have exactly k subarrays. You want k subarrays. So basically you will do k minus 1 splits, and in each split you remove difference of any two adjacent elements. So what you can do is you can just find the difference of all the n adjacent like n minus 1 adjacent pairs, and then you can sort them, and you can remove the last k minus 1, greatest k minus 1 adjacent pair sum, and the remaining you can take it. Like you need to take n minus 1 are the number of pairs minus k minus 1 smallest adjacent pairs. You can do anyways, you can just remove or add. Okay, that was all for problem A. Now let's go to problem B. This is also authored and prepared by me. So in this problem you are given an array a1 a2 an, right? And you need to take bitwise AND operator of, you need to divide the array in some parts so that sum of bitwise AND operator is minimized, and among all possible ways to divide it, you have to find the way in which there are maximum number of subarrays, right? So how to do that? So there are two cases in this, but first of all we need to understand that there is some array, and it has a subarray, and it has bitwise AND of all its element x. There is another subarray, it has bitwise AND of all its element as y, and if you merge these two arrays, say it becomes x and y. This is always going to be less than or equal to minimum of x comma y. So if you add some integer x or integer y to x, it is always going to be min of x comma y. Why so? Because if there is some bit 1 here, then it will be 1 here. If it's 0 here, 1 here, then it will be 0 here. So it will be less than y. If it's 1 here, 0 here, then it will be 0 here. So it's again less than y. And for 0 0 it's again 0. So it will be less than or equal to. So adding some element to the subarray will either decrease the value of bitwise AND of the subarray, or it will keep it equal. It will not increase. Okay. Hence we need to find the maximum subarray. Minimum subarray is just if it was flat. So now let's go on to the problem. Now there are two cases. The first case is the bitwise AND of all elements a1 and a2 and an is greater than 0. Yeah. So what to do in this case is answer is 1. Why is the answer? Because you need to minimize the bitwise AND of all the subarrays, sum of bitwise. So if you divide it into any part, suppose this is z, bitwise is z, and z is greater than 0. So if you divide it in x comma y, then I know that x will be greater than 0 and y will be greater than 0. Only then z is greater than 0, right? And x is greater than equal to z, y is greater than equal to z, and both are greater than 0. So hence x plus y is greater than z, right? If it's 0, then it's the other way. But if it's not 0, as you do, this will be greater, so we will have only one, right? And now let's go to the case where the a1 and a2 and an equals to 0. So now how to do? As you know that adding an element to the subarray will either decrease or keep the AND equal. You can just greedily take elements until you find some I, such that a1 2 and a2 and ai equals to 0. Okay, and when you get such I, you make this a subarray and you start a new subarray from I plus 1 and do the same thing. Okay, why this works is basically you need to take a1 and its subarray, you need to take a1, you need to take a2, right? You can't divide it and you can't remove a1 until the subarray as sum 0. Same goes for a2, and you will keep going this, and when you have ai you will need to maximum subarray, so you will just make it 0. So it's 0, right? So we need every subarray should have the value 0. It gets 0, go on to the next subarray, because adding it will make equal, you will keep it equal to 0. And you know, the more the elements in the subarray, suppose there is some I plus 1, there is some subarray which has AND equal to 0, there is some subarray which has AND equal to 0, or yeah. So you know that, or something like this. So you know that adding it to the here will still keep it 0, but if this is something more than 0, then it can make it less, right? So it's like adding is good, that's the thing. So you just keep adding, and suppose at the end you don't get the subarray which has some 0, then you can add this subarray to the previous subarray which has some 0, bitwise AND some 0. So it automatically becomes 0, and that's the case you need to handle as well. So that was problem B. And now let's go on to problem C. This problem is also prepared by me and authored by me. So here you are given an array a1, a2, an, and you need to find the bitwise XOR loss. Okay, so you can do some operations, and you can take any suffix and add the bitwise XOR of the suffix at the back of the array, and next time you need to take this element as well for any suffix. Okay, and and you also need to note that ai is less than 2 to the power 8 or something. So let's think about it. So what you can do is, like, you can observe, and what you might have observed is that the answer is generally the sub-array. Like, you can bring any sub-array to the back of the array. Why can you bring any sub-array to the back? Okay, so first of all, let's define f of u comma v as the XOR of subarray from u to v. Okay, not necessary u is less than v, u can be greater than v, right? This can be possible. These are just the two ends of the subarray. So subarray is from min of u comma v to max of v comma v. Okay, this is the subarray. Okay, so first time what you take is f of n comma I for some r. It can be less than 1 to n. So we say that we can say that the next time you add anything, it will be so f of, so for the kth operation, f of uk comma vk is equal to f of vk minus 1 comma vk. Basically vk equals to uk is equal to vk minus 1. Okay, so we have an endpoint which is sharing in two adjacent operations. Okay, so what's the proof for this? That there is exactly one, like at least one endpoint which is sharing when you have in two consecutive operations. Okay, so let's start. Suppose you have this condition true for first k elements. Okay, so suppose f of u2 is like f of u1 comma v1, then it's f of v1 comma v2, then it's f of v2 comma v3, and f of vk comma vk minus 1 comma vk. And now for the k plus 1th operation. Okay, so first for the k plus 1 operation, this is at the back, so you take this, right? And then you know that next element at the back is this. So, and you also know that vk minus 1, and this is all next is here somewhere. Okay, but like, let me say, write it there. Next is, so you have f of vk minus 1 comma vk, f of vk minus 3 comma vk minus 2, f of vk minus 2 comma vk minus 1. Okay, so you have this. Now if you are taking this element as well, what is the XOR of these elements? Since vk minus 1 is is a common point in both, it's nothing but the range vk minus 2 to vk. Why is this? This is also provable, but I will prove it after I prove this. Okay, so for now you can assume that if it's a common point, then the resulting array is also a subarray. Okay, so this is a common point, so it's the subarray from vk minus 2 to vk. Okay, so now from this to this, you know that this again is a common point. So now if you add this element as well, then it becomes the subarray of vk minus 3 to vk, right? And this keeps happening, and you might, if you come across, take all the elements that you have added, then it will, the first element you have added is n comma I, right? So v1 is I, so you get vk comma v1, and the next time you, so yeah, oh yeah, so no, you get n comma I, right? Because f of v2 comma v1 comma v2, and then it's n comma I. This is v1, this is u1, right? And we are having vk as one of the endpoint. Now this and this again share a common endpoint, so we get u1 comma vk. U1 is n. Okay, as first operation you do n to I, right? So this is v1 and vk, u1 and vk, where one endpoint is n and other endpoint is vk. So you have array and you have this thing. Now if you take this as well, then it becomes this thing, because n gets cancelled. If you take this, then it becomes this thing. This. So you will always have this as a one endpoint and x or x as the other endpoint, and it is always a subarray. Okay, so now let's come to the point that y. So basically you have x, y, z. You have a range x to y, y to z, but y point is comma. Then what is the XOR? XOR is nothing but x to y plus y to z, right? Because now this part and this part both are included, because now the range becomes x to z, right? Like if you have a common endpoint x to y, then it becomes x to z. Now if it's something like x z y, you have one array, subarray, as XOR of x to y and other as XOR as y to z. Y is common in both and you want to XOR both, then this part gets cancelled and it becomes XOR of x to z, right? So it's proved that when you have a common endpoint, the XOR becomes the XOR of the subarray of non-common endpoints. So hence it proved that you always get an subarray and you can get any subarray, right? So now what to do? So basically you need to find the maximum XOR among any subarray of the array, and AI is very less. So what we can do is we can have this is a quite common method, but we can have a prefix where p of I is a1 XOR a2 XOR ai, right? And you know this is the XOR. Now for each I, which are all possible values of ai, that is 0 to 255, okay, what you do is you just find if this x, which is 0 to 255, is occurring in some prefix, like some p y equals to x. If py equals to x, then you know that a1 to ay is x and a1 to ai is supposed pi, right? It's pi. So you can get, if you take subarray from y plus 1 to ai, then it's nothing but pi x or x. So for each 0 to 255 you can loop and you can find if there is some py with x, and if it's some py with x, then you can just find pi XOR x. And then before going to the next element, you also like keep that x, or like f of pi is 1, that is pi is occurring at some point. So next time you can find value of pi equals to 1. Okay, now that was problem C. Now next go to the next problem, problem D. This is again authored and prepared by me. Yeah, so this problem you have given a binary string of size n 0 1 0 1 1 0 0, and you have some ranges. Okay, yeah, and you need to find so you have to create some string t of s, something like that. Okay, so this is binary string s and this is t, and you need to find the lexicography largest t possible, and t is subarrays of s, right? So if s changes, then t also changes, and you can do operations by swapping elements in s, and you need to find the minimum number of operations you need to do in s to make lexicography as large possible for t. So let's first try making string t, right? So you have some range, then you have another range which gets added to t, then another range. You cannot actually make t because these ranges are overlapping and the size of t can be very large. But let's observe something. To make t lexicography large as possible, you first try making t1 equals to 1, then t2 equals to 1, and going on, right? And for making this 1, if it's 0, then you need to make it 1. So you need to make the position in the S which corresponds to t1 equal to 1, right? So and you have limited ones in this, so you can make only till some point you can make it. But here you go, if you have ti which corresponds to S of p, you have tj, j is greater than I, which corresponds to S of p. What corresponds to S of p? Okay, so now we can say that this tj is not necessary, it's completely waste and we should not see that. Why? So suppose you go in order, right? So if you are going to make t and suppose S of p equals to 0, so if you are going to make ti equal to 1, that means you are going to make S of I equal to 1. And when you make S of p is equal to 1, and when you make S of p equal to 1, automatically t of j becomes equal to 1. So you know that if I am going to make t of I equal to 1, I am going to make t of j equal to 1 as well. It will automatically become 1. So actually I don't want all the other indices other than the first occurrence of each S of p. The first time when S of p is taken in a range, that is the first time I am going to make it 1, and other all are just wastage of memory and time, right? So we don't need to include them, because if ti becomes 1, then tj will become 1, right? That's automatic, and we only care for I because I is occurring for previously j. So we why to take the other occurrences of any position? We only take the first occurrence, which makes the t size bound to S size, and S size is bound to n, right? Okay. So now we have the t size, and now we what to do for queries? They are flipping the bits, right? And after each flip we need to find the answer. So let's find the initial answer. What is the initial? What's happening? Yeah, let's find the initial answer. What is the initial answer? So suppose here there are x ones in S. Okay, in string S there are x ones. Then you know that you can make want to make all the first x positions t1, t2, tx equal to 1, right? So make it lexicographically as large as possible. Okay, for that you need some operations. What operations? Suppose some ti is 0, then corresponding sp is also 0. Note that this only contains the first occurrences of each position in S. If no position occurs, then that also is possible, then it won't be included in string t. So if ti is 0, that means sp will also be 0 corresponding to that ti, and you need to swap it with some 1 which is not in the first x element, right? So basically you make this 1 and you don't change any of 1 from here. So how many operations you need is just number of ones over here minus x minus number of ones over, or number of zeros in t1 to tx is what number of operations you need. And of course if x is greater than t dot size, then the number of number of zeros from 1 to t1 to t min of x comma t dot size, right? Number of zeros in this range. And now when you flip a bit, so first thing is that when you flip a bit, if that is in the first 1 to x, then you know that if it was initially 0, then it will become 1, and it reduces the answer by 1 because one operation less is needed. And if it's 1, then it increases the operation by 1 because one operation more is needed. And after you do this, you know that x is either getting x plus changed to x plus 1, or x is either getting changed to x minus 1, right? And if it's x plus 1, then you add an element which is on the x plus 1th position, or if it's x minus 1, then you remove the element which is on the xth position, right? And you accordingly change the answer. It becomes plus 1 minus 1 according to the contributing answer. This position is initially, or this position will, right? So yeah, that's the solution for D. Hope you liked it. Now let's go to the E, interactive problem. This problem is made by Archet or Starchan. Yeah, so this is an interactive problem where you ask queries in the form I, J, K, and they return 16 times area of triangle made by sides AI, AJ, AK square, side square, area square. This is basically to make an integer. They are just using Heron's formula and removing all the divisions and square root. So basically you are getting area of AI comma AJ comma AK. N is 5000 and number of queries are 5500. So let's start. Also, first thing you might do after seeing the problem is remove area of all pairs of answer. Also, if it's not a degenerate triangle, then area is going 0. So of course you remove all the pairs and you will get to know that there are 1 4 4 triple, 2 2 3 triple, if I remember correctly, are having same area. Okay, so but that might be confusing, but that is not the main logic of the problem, and we can solve it. Okay, this is only a small case. So let's start off, right? So just think that if you know I comma j such that ai equals to aj, then how can you solve the rest of array? Suppose ai comma aj is 2 or is greater than 2, then you know that all pairs of triangles with 3 comma if it's 3 comma 3 or 4 comma 4, then you can you query all x for which is not equal to I and j, and you can just get the area, and you know that which element in this and this this is one element which will be added, and that will be the answer. And all this makes all triangles possible. With these sides, all triangles are possible with 1 2 3 and 4. Now if ai comma aj are 2, okay, then if you have any ak equal to 4, then you will get answer 0, because 2 comma 2 comma 4 side don't make a triangle, degenerate triangle. And if it's any other number, then it will make a triangle, and again you can uniquely determine ak. But what if they both are 1 comma 1? Then you know that if ak is 1, then you can get the area, but if ak is greater than 1, then it will not form a triangle, and you will get area equal to 0, right? So in that case you cannot uniquely determine the elements. So here comes the problem, is that you need to find two elements equal, two positions such as ai aj are equal, right? And then you can find the rest of the array. In editorial there are 3, but it's the same. After that they use only 2, so let's focus on 2 itself, not to confuse, it's the same thing. Yeah, so you need to find ai and aj so that they are equal, right? Now how do you find that they are equal? So if, or the thing is there are 2 ones, then you can find the third one. Suppose you find the third one as well, because if there are 2 ones, then you need to find something, you need to find a solution. So you find the third one, right? And if you find the second one, and after that if there is something, if it's a third one, then you get to know a position. Suppose you know 2 ones, then how do you do is you go loop all others k, and if it's 1, then you will get the area, and you will get that the position is 1, and if it's greater than 1, then you know that it's greater than 1, right? And if you get 4 elements which are greater than 1, then that will create 2 comma 3 comma 4, and the 4th element surely will be any of 2 3 4 which is equal. So you get two equal pairs which are greater than 1, and then you can just brute on the pair, and once you get that which pair is equal, you can just do the for that many, right? So this is how you solve for 1 comma 1. So now what to do? So basically you need to find this, like you need to find two elements equal. How do you do that? There are two ways to do. The first way is this deterministic way. So in that case, you take, like, just think of the largest array where you don't get any of the two elements equal, right? Suppose that's 1 comma 1 comma 2 comma 3 comma 4. Also, if I have two ones and I have 2 3 4, still I don't get two elements equal, because with two ones I need at least 4 greater than, like at most 4 greater than this. In the worst case, that is 4, and we are assuming the worst case. I know that 1 2 3 4 5. When I go to the sixth number, it will either create triple 1, or it will create double 2 or double 3 or double 4, right? It will create one of those, and we can find what does it create. Yeah, we can find what does that sixth element create by bruting on this first 6 elements. And if n is less than 6, then again you brute and just check if it's possible or not. That's the brute force. And if n is greater than 6, again brute this, right? And you check if any pair is equal. And of course, the case where 2 comma 2 comma 4 also gives 0, and here 1 is also there, so you cannot uniquely determine this. But there is 2 comma 2 comma 3 or double 4, then again you can take double 4 and 2, right? You just don't think that you can take 6, but for safety you can take it 7 8 9 10, around that, because there are many queries. There are many queries for the second case of finding two elements equal, which is randomization. You can randomly pick 3 elements, and you can get keep randomly picking until you get 1 comma 1 comma 1 as the area. So you can pick two ones, or you get an area so that two elements are equal, something like this. So if two elements are equal, then you can just take another element ak and just brute with this, right? And just find which two elements are equal. The elements which are equal will give equal area. And of course, if it's 2 comma 2 comma 1 and 4, then that's again a corner case which you need to handle separately. But yeah, if you get to know that it's 2 comma 2 comma 1, and this is then you can again like brute again, because you know the area, so you can find that it's 2 comma 2 comma 1. If it's 2 comma 2 comma 3, then no problem, right? So you brute again, you find two equal elements, 2 2 3 3 4 4 or 1 1, and you do the thing. Why does randomization work? Just like you can, for a proof you can see the editorial, it's a short proof. But logical thinking, either you get 3 ones, right? That gives it gives the area, because 2 ones and something else will give area 0, which is not useful. So either you get 3 ones, right? So they don't will to give 3 ones, then ones will be a little less, and if ones are less, then there are more of 2 comma 3 comma 4, right? So there is a chance of getting 2 equal, and even if we get 2, we get all these 3 different, we can do another approaches. We can go on bruting, and if you get any of 2 comma 3 comma 4 using this brute, then there's a double pair, and if we get 3 times 1, still we get 3 1. If you get 2 times 1, then we can take these 2 ones and brute the remaining, because bruting with all this takes time, because one of them is 2, right? So if you take 2 comma 4, and here is also ak equals to 4, then that will give area 0, and 2 comma 3 comma 1 will give 0, 3 4 1 will give 0, 2 4 1 will give 0. So you need to brute complete to check that if that's a 4, and if you get 4, then that's that, right? So so in like 10 queries or something, less than 12 or something, you can just find 2 ones, and then you do the same approach to find 2 equal elements which are greater than 1, and you can then uniquely determine the element. Anytime you cannot uniquely determine, you print -1. It's a little implementation heavy, and there are cases That's the problem for E. Hope you liked it. Now let's go on to the last problem. This problem idea is of Jishnu or Astoria, and it's prepared by me. So let's start. We are given some array A1, A2, AN, and for all elements other than this array, or all the further array, we're just given first n elements of an array, and all other elements is an plus 1 is OR of a basically for a I equals to a I minus n, or a I minus n minus 1, right? Basically a n plus 1 is a1 or a2, a n plus 2 is a2 or a3. Okay, so like this. So let's do observations of this problem. Let's suppose that you are given an array of length 5 and the elements are a, b, c, d, e, right? So what is the further array? The further array is ab, like the further elements are ab, bc, cd, DE. You can calculate it using that n. N is 5. So first is this and this, this is this and this, this is this and this. Okay, I'm just doing that. Next is basically, okay, let's write it in a line. A, B, C, D, E, A, B, B, C, C, D, D, E. Now this element is 1, 2, 3, 4, 5, EAB. This element is 1, 2, 3, 4, 5. AB and BC, it's OR, not XOR, so you can write ABC. BCD, 1, 2, 3, 4, 5, CDE. Right. Next, let's start. 1, 2, 3, 4, 5. Which is DE and EAB, which is DEAB. 1, 2, 3, 4, 5. EAB and ABC. EABC, ABCD. 1, 2, 3, 4, 5. BCD, CDE. BCDE. 1, 2, 3, 4, 5. CDE and DEAB, A, B, C, D, E, and of course once we have all elements, the further one will be also A, B, C, D, E. You can just calculate here, A, B, C, D, E. So now if you write it in a sophisticated way, in just a table type, and I'm just rearranging some stuff, and you can see that we get let's rearrange. We need this A, we need this thing B, C, D, E. Then it is A, B, B, C, C, D, D, E. Then it is EAB, ABC, BCD, CDE, DEAB, EABC, BCDE, ABCDE, and ABC and BCDE. Right. So here you can observe that how is the position. Okay, so first let's start step by step. What is the size of each group here? Size is 4, and what's the size of array? N is 5, so size is basically n minus 1. And for each n minus 1, basically you see that A, and the last element of 1 is only one element. So you see how A moves. A moves from AB, EAB, ABC, like AB, EAB. So if you arrange them in order of n minus 1 by removing the first element and the last element, you get how A moves, right? A is in the first element, then in the next first two, then next six. And how does E move? Basically, B C D E, A B, B C, C D, D E, E A B. Basically, E is getting added to A B. Okay, then A is getting added to B C. So basically, suppose you have this array A B B C C D D E. So how it works is E gets added to AB, A gets added to BC, just B gets added to CD, and C gets added to DE. Now we go on to next group. So D is not added over here. So D gets added to first element of the previous element, which is E. So DEAB. Now E gets added to ABC. Now it's a cyclic. So A gets added to BCD, and B gets added to CD. And for this part also, A gets added to B, B gets added to C, C gets added to D, D gets added to E, and E was remaining, so we started with E over here. Right, and here now C is remaining, so C will get added to D, E, A, B, which will make A, B, C, D, E. Right. So you know how it moves. Each element gets a chance, and it's a cyclic array, and each element gets added, right? So you can make a formula of how the things are getting added, right? So basically you have 4, then 4 gets added, and the fifth one gets added to the first one of the previous one. So and each group is n minus 1, so each element gets added, right? So now what to do? So now let's assume this. Now let's assume this n minus 1 as a group, right? So now let's assume this A comma B, C comma D comma E as 0 or 1 binary. Okay, so what does we do? We initially have A, B, C, D, E. We add A to B, right? So now next time I know that everywhere B will be taken before A, because A is already added, right? So you know that wherever A is added, B is already there, 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 right? Wherever A is added, B will already be there, right? So basically if if B is 1, then why do we add A again? Because if A is 1 and B is 1, still B is added everywhere, so it will already make everything 1. So A will make it 1 late, so we don't want that. Okay, so but if B is 0 and A equals to 1, then we know that it makes this 1, and the further elements which are 0, the next time in the next round, in the next group, it will make 1. But if at some point we encounter a 1, we don't need to continue forward, because some position, from ABCDs are already encountered that. So it would be somewhere ahead of the A, right? So everything ahead of A will be 1 from that position. So work of A is done basically, right? And how many positions at most gets edited is n positions, because n positions might be 0, n minus 1, like you just change n positions from 0 to 1 at most, right? So now let's go on to each bit. So basically each bit is 0 or 1, right? And each element has that. So what you do is you do the same thing for each bit, and there are at most O of n changes for each bit, for each position, and there are log n bits. So it's O of log 10 to the power 9 n log ai, right? Only these many updates are there, right? So you know that you need to find the first position. You didn't right? So you need to find some first position. You know that x, if it's no addition to ax plus 1. If this is not getting changed, if this is not the one of the positions of n log n, you can calculate the n log n position, n log a of I. Let's keep it n log n for now. So you can calculate this n log n positions, right? And what you see that if these are not equal, then we are only concerned with this, so we remove this, right? So we sort the positions, we know the value that we add for each position, right? So we get the value for each n log n, at most n log n positions, and other positions are waste because that is equal to the previous position. And now what you do is basically you need to sort the positions, need to sort them, or if you did good job, then like I had it, you can just get the sorted positions in the sorted way, so you don't need to sort them. Why you need to sort them is because you need to find the, like you need to do prefix max, right? Because this position and this some position. Now basically for queries you need to find the first position, right? First position, which is maximum or minimum. Just a second here. What do you find in each query? Smaller first position which is greater than current, right? First position which is greater than, yeah. So basically what you do is prefix max. Why do you do prefix max? Because you can find that using binary search. So I know that a of I equals to x and a of j equals to y, where these both are edited positions. I'm now only talking about the n log n positions, okay, where j is less than I. So I know that smallest position, and suppose this y is greater than x, so I know that if y is greater than vi for the query, I need to find this is the first position, and x doesn't matter. And if x is the answer, then surely y is the answer again, because our y is greater than x, right? So you need to find the x will be max of x comma y, so that it's an increasing array and we can actually binary search. Else for each position you need to find the max till that range for binary search, right? Basically you find max till that position. So that's why you do prefix max, and then you can just find the binary search and find the first element y which is greater than v in the array. When there is no element, then answer is -1. Else you first find element y, and that will be the answer. And the other elements which might have become max same equal to y, because like this x doesn't matter, but we can removing them, it's better to keep them. So that's the answer. If you do sorting, then line complexity is a little more, but it's a similar, like solution take time. So yeah, that was editorial for all the problems. I hope you understood all the approaches and liked the video and the problems as well. Thanks for watching my video. Don't forget to like, subscribe and comment.